Each of the 3 questions in this video features a different trap common to GMAT absolute value and inequalities questions. I'm going to teach you how to identify clues in the problem that help you notice these traps and avoid them. I'm Erika with Target Test Prep, here today with another 3 levels video, this time on GMAT inequalities and absolute values. Now, if you haven't seen one of these before, we're going to go through 3 levels of inequalities and absolute value GMAT questions. 1 easy question, 1 medium question, and 1 hard question, where only 19% of Target Test Prep GMAT students get the hard one right. Let's jump in with the easy question to get warmed up, and subscribe for new videos from me on Wednesdays. Pause the video if you want to try this one on your own. Now, this problem gives us a relatively simple inequality, 2x plus 5 is greater than 7, and asks us to find a possible value for our variable, or x. Pretty straightforward. We'll start by manipulating our inequality to isolate x. So first, we'll subtract 5 from each side, giving us 2x is greater than 2. And then we'll divide both sides by 2, giving us x is greater than 1. At this point, 10% of people choose answer choice D, and that is wrong. Our inequality tells us that x is greater than 1. If you've seen my video on 16 careless math errors, you know that stopping a step short is a classic mistake, and that is exactly what can happen here. Our final step is to recognize that the only answer choice greater than 1 is 2, making the correct answer. Now, most test takers get this problem right, but what if we were moving quickly and got a little too excited about seeing a 1 in our answer choices? Well, if we're about to pick D, there's a clue that we've made a mistake, and that's that our work on this problem so far was a little too quick and a little too easy, even for an easy problem. There hasn't been any sort of trick or trap yet. It's just been math, and basic math at that. And we know that these problems don't really test math, they test critical thinking. So this should prompt us to pause and think, what's the trap? Where's the opportunity to think critically? And this alone may be enough for us to catch our mistake and realize that there's another step. But if not, a great way to check our work in a problem like this one is to use plug-and-chug to confirm our answer. If our answer is correct, plugging it in for our variable should give us a true equation or a true inequality. So plugging in 1, we get 2 times 1, or 2, plus 5 is greater than 7, or 7 is greater than 7. Now, some folks who are really not paying attention may go, the sides are the same, and still pick D, but this should be more obviously wrong. So this should lead us to the realization that x must be a greater value, of which there is only 1, 2 in answer choice E. Now, if we want to plug that in to confirm, we get 2 times 2, or 4, plus 5 is greater than 7. So that is 9 is greater than 7. That is true, confirming that E is the correct answer. Now, we also could have approached this problem with plug and chug from the jump, trying each answer choice and implementing process of elimination until we reach our correct answer. And that absolutely works, but it can be a little bit slower than algebra. A good move to save time is starting with our middle and coincidentally easiest to plug in answer choice, x equals 0. Now, when we plug this into our inequality, we are going to find that it is too small, too low of a value. So x must be greater than 0. This means that not only can we eliminate our answer choice 0, we can eliminate the answer choices that are smaller than it, so A and B as well. This saves us time by allowing us to focus our time and energy on evaluating D and E. Now, starting with the middle answer choice is not a trick that works on every question, but it does give us some efficiencies here. All right, let's ramp up the difficulty a bit with the medium question. If you want to try this one on your own, once again, pause the video. Let's start with how test takers go wrong on this one. The pretty obvious approach here is to square root each part of this inequality, so we end up with just x in the middle. So test takers go, great, the square root of 225 is 15, so that's less than x, and the square root of 400 is 20, so that is greater than x. So we have 15 is less than x is less than 20. So this means that x is an integer between 15 and 20, but not equal to 15 and 20, meaning that x can be 16, 17, 18, and 19. Now, since we are solving for the sum of all of the possible values of x, we're going to add those up. So 16 plus 17 plus 18 plus 19, which equals 70. And at this point, they pick answer choice E. Around a quarter of test takers pick this answer, and it is wrong. So let's back up for a second. Most people know that when you have an absolute value in an inequality, you need to consider both cases, whether the thing in the absolute value is positive or negative. So this means creating two inequalities, one where you simply drop the absolute value, and this represents a positive value inside that absolute value, and one where you drop the absolute value, flip the sign, and make everything on the other side of it negative. And this represents a case where the thing in the absolute value is negative. What fewer people realize is that when we have a square or any other even exponent in an inequality, to get rid of it, we need to do the same thing. And that's because the square of x squared isn't really x. It's the absolute value of x. So once again, we need to consider both cases, where the thing being squared is positive and where the thing being squared is negative. So in this problem, 15 is less than x is less than 20 is one of the inequalities we get out of our original inequality. But the other one is negative 15 is greater than x is greater than negative 20. Or flipping that around to make it easier to read, negative 20 is less than x is less than negative 15. This gives us four more possible values for x: negative 19, negative 18, negative 17, and negative 16. Now we could add these to our other values for x and see what it gives us, or we could realize that these are simply the negative versions of these values, which means that adding them together will cancel each other out, giving us a sum of 0, or answer choice B. So getting this question right out of the gate requires an understanding of this pretty specific algebraic rule. But what if we didn't remember this rule? Or what if instead of square rooting each term, we instead decided to rewrite our inequality as 15 squared is less than x squared is less than 20 squared, which more obviously leads us to the positive versions of our values for x. Well, once again, let's pause for a second. Like our first problem, that would be a little too quick, a little too easy. So what's the trap? Now, because our answer choices are the sums of the possible values for x, plug and chug is not going to be a viable approach to check our work. But we can still use our answer choices as clues. If we give those a scan, the presence of 0 should hopefully give us pause. It's a weird number, especially for a sum. So thinking about that for a second, we should realize that to get a sum of 0, we would need negative values as well as positive values in order for them to cancel out. And this should remind us that squaring a negative number is going to give us a positive number. And that should then lead us to the idea of negative versions of our values, which then finally leads us to our correct answer. Time for a challenge with the hard question. Again, this stumps 81% of Target Test Prep GMAT students. All right, this problem has an absolute value. My first move is going to be to isolate it. So I'm going to subtract 2 from both sides. And while I'm at it, I'm going to flip the equation around so that my absolute value is on the left. You don't need to do this, but it's a little easier to read and work with that way. So that's going to give me negative absolute value of x minus 1 equals x squared minus 5x plus 4. Then I'm going to multiply both sides of the equation by negative 1. So that's going to give me the absolute value of x minus 1 equals negative x squared plus 5x minus 4. Now, just like with absolute value inequalities, with absolute value equations, we need to consider both cases. So here where x minus 1 is positive and where x minus 1 is negative. Now, fortunately, equations are a little bit simpler to deal with than inequalities since we don't need to flip a sign. So our first equation is just going to drop the absolute value. So x minus 1 equals negative x squared plus 5x minus 4. And our second equation is going to drop the absolute value and then make everything on the other side negative. So multiply by -1. So negative x squared becomes positive x squared, positive 5x becomes negative 5x, and -4 becomes positive 4. Now, at this point, we can see that each of these equations has the elements of a quadratic. So we're going to go ahead and manipulate these to get all of the terms on one side so that we can factor like we normally do with quadratics. Now, when I am manipulating quadratics, I like to manipulate them such that my first term, my x squared term, is positive. So in this first equation, I'm going to move my terms from the right side to the left side. So that's going to give me x squared minus 4x plus 3 equals 0. And then in the second equation, I'm going to manipulate so that my left side terms go to the right side in order to keep this term positive. So that's going to give me x squared minus 6x plus 5 equals 0. From here, we're going to factor, and this is where having a positive first term really helps, at least for me, in not making factoring errors. So in this first equation, we're going to get x minus 3 times x minus 1 equals 0 for solutions of 3 and 1. And in the second equation, we're going to factor for x minus 5 times x minus 1 equals 0 for solutions x equals 5 and x equals 1. Now, at this point, more than 60% of test takers say, great, well, 1 is a duplicate solution, so our 3 solutions are 1, 3, and 5, which multiply together to a product of 15, which, hey, is answer choice E. And that is wrong. But why? Well, again, if you've seen my video on 16 careless math errors, you know that a classic mistake is neglecting to check for extraneous solutions, which I'm going to write right here. Now, in that video, we outline the cases in which you need to check for extraneous solutions, but one of those cases is when you have absolute values, since the manipulation we do to get rid of the absolute values can introduce solutions that don't actually work when the absolute value is present. So what we're going to do is plug in our 3 solutions to confirm that they actually work in the equation when the absolute value is there. Now, I'm going to go ahead and plug them into the version of the equation right before I got rid of the absolute value, since it's the simplest version of that equation, but it doesn't matter. You can plug it into the original and it'll still work. Now, normally I would start with my smallest solution and work my way through them in ascending order, but a little trick to save time here is to recognize that since this question is asking for the product of the possible values of x, whether or not one is a valid solution versus an extraneous solution doesn't actually matter, because multiplying by 1 in a product does not change the answer. Now, if you do end up plugging it in this version of the equation that we chose, I think it gives 0 equals 0. If you plug it into the original, I think it gives 2 equals 2. In any case, it's true. And this is, in fact, a valid solution. But because it doesn't matter, I'm going to go ahead and skip it and save some time. All right, next up is x equals 3. So the absolute value of 3 minus 1 is equal to negative 3 squared plus 5 times 3 minus 4. So the absolute value of 2 equals negative 9. Remember, we are not squaring that negative. Plus 15 minus 4, or 2, equals 2. This is true. So 3 is, in fact, a valid solution. Next, we'll check 5. So the absolute value of 5 minus 1 equals negative 5 squared plus 5 times 5 minus 4. So then we have the absolute value of 4 equals negative 25 plus 25 minus 4, which gives us 4 equals negative 4. Uh-oh, that is not true, which means that 5 is in fact an extraneous solution and not a possible value of x. So our only true possible values for x are 1, which again does not matter for this particular problem, and 3, giving us a product of 3 for a correct answer of B. Now, unlike the last problem, this problem took ages. So when we get to our 3 solutions, we didn't have a quick solving process as a clue that we were still a step shy of our correct answer, which is one of the reasons that around 3 times as many test takers get this one wrong. But we can still find a clue in our answer choices if we're paying attention. And what I notice is that each of our 3 original solutions is present in the answer choices along with the product of all 3. Now, why is that? By and large, wrong answer choices are there for a reason, because there's something you might think is the correct answer. And maybe they're here in case we neglected to consider both cases for the absolute value. But that isn't a super common mistake unless you really don't know anything about absolute values. It's kind of the point of absolute values. In fact, when we think about it, even though this problem took a long time, there wasn't really anything tricky about it until we reached the extraneous solution. No real opportunity to think critically. So why are these answer choices here? This should prompt us to think about the possibility of one of these solutions not really being a solution. And this should lead us to plugging them in to the equation with the absolute value to confirm their validity. And this should then save us from picking E. Now, there are a number of absolute value and inequalities concepts that did not appear in the 3 questions we looked at today. Absolute values in inequalities, equations with multiple absolute values, systems of inequalities, which are actually one of the 9 uncommon question types that I cover in my most recent video, so check that out, as well as the expression of inequalities and absolute values on the number line, and so on. So I recommend continuing your study beyond the problem types we saw today. But just like we talked about today, remember that new concepts come with new traps, and that those traps can be easy to fall into if we aren't vigilant. So be on the lookout for clues that indicate 1, that there is a trap we haven't noticed, and 2, what that trap might be doing. I hope this video helped you, and please give it a like if it did. Thanks for watching, and I'll see you in the next one.